In this video, we'll talk a little about architectural design, and we'll look at an example using the Safe Home software. Architectural design starts with a context diagram that shows how the system you're building interacts with external entities, including other systems. Once you have this information, you typically look for high-level patterns that involve the components of your system. Unlike in the analysis model, which primarily includes components from the application domain, architectural components can also be infrastructure or interface components. Here's a generic architectural context diagram. The target system is in the middle. Above it are the systems that use the target system, and below it are systems that the target system uses. In this diagram, Pressman has one-way arrows from the superordinate systems to the target system, and two-way arrows from the target system to the subordinate systems. Now, it seems to me that if the arrows are really meant to suggest the potential direction of data flow, both sets of arrows would be two-way arrows. So I'm not really going to emphasize that difference here. To one side of the target system, we have the external entities, or actors, that interact with the system. And to the other side, we have the peer systems. Here's an example of an architectural context diagram for the Safe Home security function. Recall that the security function involves various sensors that send data to the system. The sensors are subordinate systems. The Safe Home product as a whole, and remember our target system here is just the security function, is a superordinate system. The control panel and the homeowners are actors here, and the other Safe Home functions like the surveillance function are going to be peer systems. Here's what Pressman says about archetypes. An archetype is a class or pattern that represents a core abstraction that is critical to the design of an architecture for the target system. In general, he says, a relatively small set of archetypes is required to design even relatively complex systems. I think the key takeaway from this is that you should try to keep your architecture conceptually simple. Make it easier for other developers to understand your architecture by minimizing the number of important design decisions they have to keep track of. In this example, Pressman has a controller with potentially multiple nodes that communicates with other controllers. A node can be a detector or an indicator. In the context of the Safe Home security function, detectors would be the sensors, and indicators would be the alarms. Because sensors and alarms are both handled with the same kind of controller object, you don't have to comprehend two different designs to understand the architecture. There's a difference in the kinds of components you see in the analysis model and the kinds of components you see in the architecture. Components in the analysis model are drawn primarily from the application domain, but components in the architecture can be not only from the application domain, but they can also be infrastructure components or interface components. The components highlighted in blue here are infrastructure components. They often have names like manager, processor, or controller. This slide illustrates the notion of component elaboration. A component may be as simple as a class in an object-oriented language, or it could be a set of smaller components. So a single component can and should be elaborated into its constituent parts. You can stop elaborating when you get to the class level, or the level of a cohesive module that serves a single well-defined purpose, in a non-OO language. In this figure, we're elaborating the security function from the previous slide. In the previous slide, the security function held three components: the control panel processor, the detector manager, and the alarm processor. These three components have been elaborated here to show the components that they contain. In this diagram, the additional components are highlighted in blue. And that's it for this module on design engineering and architecture. In the next module, we'll talk specifically about component design and some of the key principles involved in that.